Hello, Year 11. We're going to continue with our discussion on discriminants today. So last time we talked about the quadratic formula, which is this right here, should look familiar. Just this part underneath the radical, or in the surd, is your b squared minus 4ac. That's called your discriminant. And if you think about the word discriminant, it has the prefix, the discriminate. It's where it's really coming from. So to basically differentiate between something and decide whether you're going to use it for one way or another or whatever the case is. So we are actually discriminating between how many roots or how many solutions a quadratic equation actually has. So we're going to be looking at just the b squared minus 4ac part to tell us that. So if b squared minus 4ac actually equals to 0, think about what that means. That means you have x equals negative b plus or minus 0 divided by 2a. Well, if you have that equal to 0, if you have the discriminant equal to 0, that means I'm not taking the square root of any number. So I really just have negative b divided by 2a. That winds up being our axis of symmetry, or the x value of your vertex. So what you wind up seeing is that if you wind up having a quadratic equation that you graph and you make this beautiful parabola, you wind up noticing, So what you'll notice is that your parabola will be sitting directly on the x-axis. Here's your axis of symmetry, and your vertex lies on your axis of symmetry as well. So that one solution is actually a repeated solution or a double root, because both of your factors, if you were to factor a quadratic like this, you wind up getting the same factor for both. So for example, if you started with something like x minus 3 times x minus 3, if that was your quadratic and you set that equal to 0, you would get two of the same answers of 3. So that really comes from the quadratic of x squared minus 6x plus 9 equals 0. So if you were given that x squared minus 6x plus 9 equals 0, and you were going to factor it, you would get the same two factors, which would mean you'd have a double root or repeated root at 3, which is what my picture is showing. All right? And that would also mean that your discriminant was 0 if I tried to do that. So if we were to use the quadratic formula for this one, you'd notice exactly what we were just talking about. That discriminant winds up being 0, and therefore you wind up getting your solution as just 3. For our second scenario, if your discriminant winds up being greater than 0, so if you're looking at b squared minus 4ac, and that winds up being greater than 0, then you're looking at a case where you're actually going to have a number underneath the surd, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you have some kind of number in there that I can actually take the square root of. It's a positive number, it's greater than 0. So that means I'm going to have two places on my graph where I'll be crossing the x-axis. So it might look, you might have a parabola that looks like that, where it crosses on the left and the right of 0. You might have one that is upside down and it crosses here. Whatever the case is, you'll have two different solutions since you're taking the square root of it, of your discriminant, and then adding and subtracting it from the negative b. So one example is if your discriminant is a perfect square, so for example, this 2x squared minus 7x plus 3. If I wound up factoring it, I can actually factor it. And if I wind up using the quadratic formula, you'll notice your discriminant comes out to be 25, which is a perfect square. And if it is a perfect square, then I get this wonderful integer that I can add and subtract from the 7, and I get my two answers down below. So that's one example. If you do wind up having a perfect square as your discriminant, it can be factorized. And in a second example, if you have x squared plus 6x plus 1, I can't actually factor this one, and you'll notice that you can't factor it because your discriminant winds up not being a perfect square. So if I take the square root of that 32, my discriminant, I'm going to wind up simplifying it down to 4 root 2. Or if I use my calculator, I'll get a decimal for that one. I can still get two answers, so I still have negative 3 plus 2 root 2 and negative 3 minus 2 root 2. However, notice that I can't actually factorize it. So that's a little hint to know whether you can actually solve by factorizing or not if you find the discriminant first. And in our third example, we have the discriminant which is less than 0. So think about what that means for a moment. If you take b squared minus 4ac, and that winds up being less than 0, that means it's going to come out to be a negative number. If you wind up using the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, and this is a negative number, can we take the square root of a negative number? All right, we're going to wind up getting something that's called an imaginary number. So if that is the case, we actually do not have any real roots. So that means that our parabola is either sitting above the x-axis or below the x-axis, but it's not actually going to cross. So we will not actually have any real solutions, no matter how we try to solve this. So an example for this one would be y equals x squared plus x plus 5. If I do wind up finding the discriminant, or maybe I start by trying to use the quadratic formula, look at what happens. So if I set up my work and I wind up taking b squared minus 4ac, I'm getting negative 19. So I actually cannot simplify negative 19 any further, but I have my solution. This is my answer right now. It is exact, but it just means that my graph actually does not wind up crossing the x-axis. So I have no real solutions or real roots for this problem. All right, guys, so for one example, just to keep you thinking before you head to class next time, this is a very typical IB question where they won't just ask you to directly find the discriminant, but you have to either use the discriminant or do something with the discriminant to then try to figure out something else. So if you look at this example here, you're given x squared minus 2x plus m is equal to 0. This symbol meaning discriminant, it's a reminder. And then they throw in this value. They don't actually give you the third term of your trinomial there, of your quadratic, but they give you m. So m is what's known as a parameter. That is something that's kind of limiting or setting up your equation. And your variables are still x and y. So again, right now, x is part of our equation and y is being set equal to 0. So we can solve our quadratic. So for our very first part of this question, it's asking you to make sure that you can find m in terms of this quadratic having repeated roots. So if this quadratic is going to have repeated roots, remember that repeated roots means that you have two of the same factors, which means that I'm going to have my discriminant equal to 0. So if my discriminant equals 0, that means I need b squared minus 4ac to equal 0. So in my case here, b squared would be negative 2 squared minus 4 times 1 times m equal to 0. That gives me 4 minus 4m equals 0. If I add 4m to the right, I have 4 equals 4m, which means that 1 is equal to m. So therefore, m must equal 1 if I want to have repeated roots, which would mean that my discriminant should equal 0. So just look at an example for a moment. Always test your work and see if you trust what you did was correct. If m is equal to 1, then my quadratic would be x squared minus 2x plus 1. That's funky. Plus 1, there we go, is equal to 0. So if I factor this, I'll have x times x, 1 and 1 minus, so x minus 1 times x minus 1 would give me x squared minus 2x plus 1. And if I set that equal to 0, it actually is correct. I wind up having a repeated root at x equals 1 because I have two matching factors. So for the next two, part B and part C, once you find your answer, also go ahead and test an example and see if you trust what you found. So for us, for part B, again, remember if I want two distinct real roots, right? Real roots means I want my discriminant to be greater than 0. So now I'm going to take my same discriminant that I set up in part A. So I have, if you guys look at where we started off here with our basic formula for a discriminant, then here we have our values substituted in. So this is really where our discriminant was simplified as much as we could have it. So let's go from that step. 4 minus 4m, we want that to be greater than 0, which would mean 4 has to be greater than 4m, which would mean 1 has to be greater than m, so therefore m must be less than 1. So go ahead and choose a value less than 1, and see if you agree that it will give you two distinct roots. And then for our last example, no real roots, which means I need imaginary roots, so I need my discriminant to be less than 0. Again, I'll start from that same point. 4 minus 4m less than 0 implies that 4 is less than 4m, which implies that 1 is less than m. So therefore, m has to be greater than 1. Again, choose a value for m greater than 1, substitute it in, and see if you agree that that is actually what you wind up with, is having no real roots. So at the end of your notes, always go back and summarize. Did you actually pick up the fact that this is actually what we're looking for? If you have a discriminant that's greater than 0, you are looking for your two distinct linear factors. So you have two separate different factors, and they'll give you two real roots that are different. If you actually have your discriminant equal to 0, that's when you have a repeated root. So that means your two identical linear factors, they'll wind up looking exactly the same, which would mean they're going to be repeated. And last but not least, if you have your discriminant less than 0, which is going to give you a negative number underneath the square root, you have that negative number, then you'll wind up not being able to factorize, and you won't get any real roots. So you'll have to leave your answer with a negative or with an imaginary number in it. All right? Go ahead and look back over this. Make sure that you understand how to practice the problems that we went through and that you get the same answers. Otherwise, make a note to ask about it tomorrow or next class.